G'day guys, I've had a few requests for me to tackle the chain rule and explain what it's all about, when we need to use it, etc, etc, etc. So what I've done is I'm going to try and explain it to start with, and I've got a couple of questions here that we need to use the chain rule to solve. So let's get to it. Now, hopefully you guys are all fully aware and basically become experts at basic differentiation. We know how to differentiate basic functions like y is equal to, say, like an x cubed. You know, we know that y prime is equal to 3x squared. We don't need any help with any of this sort of stuff here. So this is all good, hopefully. So what we're going to do is you're going to run into functions sometimes that are like this. If we had something along the lines of y is equal to the let's not start with that. I don't want to go too gnarly too early. I'm just thinking on my feet here. If we had something like this, 3x squared plus 4x all to the power of 6. Now, we can't solve this using the method described here. We can use parts of this method to solve this, but we're not going to be able to get the derivative of this without using what we call the chain rule. Now, what the chain rule is about is it's when we can see a function contained within another function. So what I mean by that is here, in this example that I've given, we've got this quadratic function, which is contained within this sixth power function. So what we have is we have a function within a function. So what we can do is we can describe this as y is equal to u to the 6. I'm just using a random value to substitute. And I also know that u is equal to 3x squared plus 4x. So you can see that I have a function and another function within it. So what the chain rule states is if I want to get the derivative of y in terms of x for this sort of function contained within a function, if I want to find this, what I have to do, so if I want to find dy dx, the way I'm going to do this is I first differentiate the outside function, so dy in terms of u, and I multiply that by the derivative of the inside function, du dx. So basically what happens here is, like in this case, the u's cancel and we get dy over dx, which is what we're looking for. So if we were going to differentiate this, if we wanted to find dy dx, first of all, we differentiate y in terms of u. So that would be, we can use our basic differential mechanics here. So 6 u to the power of 5. And we're going to multiply it by the derivative of this one here. So let's put it in brackets just so we don't get it mixed up. This is going to be 6x plus 4. So then what we can do is once we've found the derivative like that, we can then substitute our u value back in, and we get 6u, which is 3x squared plus 4x to the power of 5 times 6x plus 4. And we can simplify this, but that is our basic derivative there. So what we can see is we've differentiated the outside function with respect to our substitution variable, and then we just differentiated our inside function with respect to x, and we multiplied them. We then finally substituted what our value was for u, and then we have a derivative. We're good to go. Happy days. So let's take this method, and I'm going to try and go as slow as possible, but let's take this method to these problems here. So first of all, we're going to determine the gradient of each of the following at the given point without the assistance of our calculator. Okay, so first of all, when we're trying to do the chain rule, we need to identify our functions. Like if you're new to this, you must identify your functions. So here, our outside function is going to be y is equal to 1 divided by u to the power of 3. you can see that like I can pull out that quadratic that's sitting in that bracket there. And it's nice that they've given us that bracket, to be honest, because it makes it easier to see. And our inside function is just going to be, let's put a nice comma, separate them out, u equals whatever's in the bracket, 2x squared plus 1. Nice. Okay, so the chain rule states, now let's write it down, that the dy dx is equal to dy du, the derivative of the outside function with respect to our substitution variable, multiplied by the derivative of u with respect to x. So let's do that. In this case, this value here, let's just make it look a bit easier so we can see the differential. This is just going to equal y equals u to the negative 3, just a few index laws. So if we differentiate that, we're going to have negative 3 u to the negative 4. So that's going to be negative 3 divided by u to the power of 4. We're going to then multiply that by the derivative of u with respect to x. So this u with respect to x is just going to be multiplied by 4x. Cool. We can then simplify this. I'm going to put the 4x up the top. So 4 times negative 3 is negative 12. I'm then going to also substitute back in what u is equal to, 2x squared plus 1. To the power of 4. So there's my derivative. Now I have to work out so once I've got that, the next step is I have to figure out what the gradient is. So I'm going to evaluate my derivative, dy dx, evaluated when x equals, 0. So if I substitute, there's got to be an x up the top here as well. 4x times negative 3 is negative 12x. So when I put 0 into this equation, I've got negative 12 times 0. I have a 0 up the top. And at the bottom, 2 times 0 squared is 0, plus 1 is 1 all squared. So 0 over 1 is a 0. So our derivative when x equals 0 is 0. We can write it, there are all these different other ways to write it. We could have written it f prime at 0 equals 0, but you get the drift. You can see how I separated out my functions, used the chain rule, found the derivative, substituted in my x value, found what the gradient was. Happy days. So let's take this to the next question. So hopefully you guys are aware that like when we have, because this function here is a little bit different to this function, as in it's only the back bit which requires the chain rule, not the front bit. So hopefully you guys are aware that when I have like a y equals x cubed plus say 4x squared minus 1, I do the derivative of this, and this all separately. So what I can do is I'm going to do, like if I want to find dy dx, I go dx cubed dx plus d4x squared dx minus d1 dx. So you can see that each of these I can differentiate them separately, and that's just how the algorithm works. So I'm going to apply this basic sort of these basic principles to how I'm going to differentiate this one, because I'm only going to use the chain rule on the second part. So I'm going to say that dy dx is equal to dx squared dx plus dx minus 1 all to the 5 dx. Alright, so we can start with the first one. It's not too complicated. Is dx squared dx is 2x. Now let's take this one over outside. So we have this x minus 1 all to the power of 5. Well, our outside function is going to be y equals u to the power of 5. Hopefully that's quite easy to see. And we can then see that our inside function is going to be u is equal to x take 1. So when I'm differentiating this part of our function, we're going to go, this is going to be equal to plus dy du, which is going to be 5u to the power of 4. 5u to the power of 4 times by du dx, which is just 1. Cool. So what I can then do is I can substitute all this in. So this is going to be equal to 2x plus 5, put u back in, x take 1 to the power of 4. And that is our derivative. So then what we're going to do is, to finish the question off, change the colour. I'm going to get dy dx evaluated when x is equal to 2. And that's equal to 2 times 2 is 4. 2 take 1 is 1 to the power of 4, or is still 1, times 5 is 5. So another way we could write that is we could say that f dash of 2 is equal to 9. So basically you can see that what the chain rule is doing is it allows us to differentiate basically what I'd like to call compound functions. So functions within functions. Like another one we could say is if we had, say, y is equal to sine of x squared plus 2x. So you could see that this would be very difficult to differentiate, like without the use of the chain rule. Because what we'd have to do first is we'd say that y is equal to the sine of u, and u is equal to the quadratic that we have within the bracket. So basically then we'd go dy du, du dx, and we'd multiply them. Now, like these sort of compound functions, they become quite easy to do once you get good at identifying where the inside and outside functions are. They just require practice. You can see that once we've identified the inside and outside functions, to start with, it'd be good if you just wrote down what the chain rule was over and over and over again. It also allows you to have a scaffold or a structure to hang your differential off. And it also allows the teacher to see that you know that you have to use the chain rule. Because if you cock up the differential at the end, then at least you've got, you might get some marks in an exam style situation by writing down, yeah, I had to use the chain rule. So I hope this video helped. It's a bit haphazard sometimes, but just keep working through them. There are heaps of other videos online. I'm pretty sure I do a few other chain rule videos as well. But until next time, if you like the video, hit the like button, subscribe to my channel. I make new videos all the time and I don't have any problem responding to requests. So let us know what you think and I'll see you again next time.